There's only one R file. This lecture is a little different from last year. I dropped some things. So if you want to watch the ones from before, that's fine, but there's a little bit of tweaks and changes because Ggplot also updated. So I'm just going to re-record this one to be exactly what you have to know for the semester, but you can, if you need another one, there's more from last semester as well. So it'll be 3 semesters worth of Ggplot because it is a lot at once. So the book mentions this doing statistics with R package that you can use to do stuff. That is not a thing. It does not exist. So anytime it talks about functions from that package, that's not a thing. So we're going to do other functions that work the same. So just kind of a warning because it's in the beginning of this chapter, either chapter 3 or 4. So this is a suggestion, but it's not really a suggestion. This is, I'm going to tell you to do it this way for a lot of reasons. So we're going to talk about stacking your code a lot today. So if you have the code open of mine, you'll notice that it has lots of indents in it. This is something they teach you in regular programming too, and I was always sort of like, whatever, until I got serious into programming, and it just makes your life so much easier. The code for Ggplot gets really long. There are sections that you can just cut and paste and use over and over again, but it can get quite unwieldy, 20, 30 lines. And if it's all one huge line, you're never going to figure out what the problem is. So you should stack your code. And I'll show you what that means in a second. So at some point, you will be able to troubleshoot it easier, but really that'll help us help you troubleshoot it. So if your code is like all viewable in one screen, I will be able to see them a lot better. It helps you see what's going on, and I'm basically telling you, you have to do it. Okay, so there are a lot of good reasons to do it, and the nice thing about Studio is that, let's say you're typing it manually and you're not cutting and pasting, it actually will help you stack the code nicely. But that's a lot for troubleshooting. And so it's more of a visual thing. It doesn't actually change the way the program runs or the syntax runs. It's really more to help when you have issues or want to be able to read the code. So stack your code. And so here's an example of what that looks like. So this is one plot we're going to get to at the very end, a line plot. And so all of this just makes one graph. But it's nice to be stacked so that I can tell that everything here, so this is the first part of the plot, all of these things are a main point, something we're adding to the plot. And then these double indents go with the line directly above it. So you can tell where the lines kind of go together. And that's all viewable usually in one screen. So if you have a problem with the code, it also sometimes in Studio will give you a little X on the side. I don't know if you've seen that. Sometimes it just wigs out and does it on all the lines. But that'll help you say, oh, it's this line that's the problem. But if you had put all of this on one line, which you can do, it would be like, I don't know where the problem is. Okay. It's just easier to read. It's easier to troubleshoot. And hopefully easier to tell when there's an issue. Yeah?
What are those pluses?
Those pluses are telling it to keep going to the next line. We're going to get there in a little bit. So that's where we're headed today. So we're going to start with chapter 3, but we've done a lot of chapter 3 already in lab. So we're only going to talk about some things that we haven't covered. So file functions, factor functions, and rearrangement functions. Okay. So we've already talked about how to do the import function, but that only really works for CSV files. So most of the things I'm going to give you are going to be in CSV. Every once in a while I'm going to throw an SPSS file at you to make sure that you can remember how to do this. Because people work in different formats all the time. Right, so I have some friends I collaborate with a lot. They exclusively use SPSS because I haven't managed to convince them this is better. So when they send me files, I don't want to constantly be opening SPSS and changing the file type, and some of you may not even have access to open SPSS. Right? So what do we do if we have something else? Okay. And mainly this is going to cover how to open SPSS files. If you have other types of text files, I can show you how to do those too. Okay. So this is going to be the Misc Library for miscellaneous something or another, and so you got to be sure to load the library. So I'm not sure if you guys have that one installed. Okay, so I'm going to make this bigger. Bigger. bigger, bigger. I'm going to move out this way. Okay. So first thing you'll want to do is set your working directory to where the folder that you saved all this stuff. Okay. This one is the one from my computer when I was testing it, but let me try setting it for this computer. So I'm going to go Session, Set Working Directory. I'm going to choose, and I know it's all in this folder, so I'm just going to hit Select Folder. Don't forget you can click the little arrow here and make sure all these files we're about to use are popping up here. Okay. So they've got to be here for these lines to work, or none of the stuff below is going to work. So we're going to install Mmisc and Reshape. I can't remember if we installed Reshape on the last. You have these already, but that lab we did. But either way. You should have Ggplot installed. And then let me know if anybody has any trouble installing packages, because Reshape sometimes freaks out. 2 seconds. Let's see, where are we at? Here. Okay, so you have to install the library, which hopefully we got all the kinks worked out, but also be sure you load the library. Okay. Once you install them once, you don't have to install them again. If you're on the school computers, you will, but if you have this library, you don't have to reinstall it every single time. Okay. So make sure they load. And if you aren't sure if they're loaded or not, you can click on Packages, and they should have a little check next to them. So here's something new that's kind of fun that a student showed me. If you have 4 number signs, it actually pops up here as a place it's kind of like a marker or an outline marker, so that you can jump between things in the code, which is really handy if you're doing a lot in one code. So when you get to your homework or the lab and you're like, okay, I need to do a scatter plot, you don't have to like scroll through everything. You can click here and it'll take you right to that spot. So yeah, it's right here under the script. And we're at read SPSS. And it's as long as you put 4 number signs, starting in the line with 4 number signs. Yeah.
My reshape isn't loading.
Oh, sorry, that was the same problem. That oops, don't do that. All right. Reset. Happiness. Okay, no problem. Okay, so it's 4 number signs, and then it creates this little thing right here.
Is that the B? Both sides?
But I think so. Let's test this theory.
Yeah.
Yeah, it's both sides. And that just gets really nice when you have a lot of code. The other thing it does is it creates you this little down arrow, and you can close up sections. So I don't want to deal with this right now. I can kind of close them. It just hides the code from you. It doesn't delete it. That's nice if you have a really long piece of code. So that's something we found out kind of by accident. All right, so to load datasets, I don't think I have it called chip2. I forgot to fix that, but whatever. It's this function. There's 2 functions together. And it's sort of a weird, you have to like force it into R and then change it into something usable. So the first function here is SPSS system file. So that's just telling R, here's the type of file we're pulling. And then there's this as data set. If you try to run it without that, it doesn't work. So a data set and a data frame, different things. But let's load it and I can show you a little better. So if I flip over to Studio, this is line 12 in mine. Okay. So I just called it chick data because it's a data set about chick flicks. These are from the book. Okay. And so as long as your working directory is set where you can see these files, these next lines should run. And this is why working directories are so great. And so the only thing you would need to change if you wanted to use this on your homework is the name of the file right here. So one thing I try to do, and sometimes I'm slightly inconsistent, so always feel free to ask, is anytime I give you code, like in PowerPoints here, I try to italicize the thing that you have to change. So all the rest of that stays the same. You can come up with whatever name you want to call it. But the thing in italics here is what you need to change. So you don't change system file or has data set. All right, so a data set, it comes up here under values and it says formal class data.set. And I can use my little drop down arrow and look at what's going on. Okay. And it's a special type of object in R that we pretty much never use, because it doesn't really work the way we want it to work. And I also can't click on it and see it. So what we're going to do is just transfer it into a data frame, which is all that air quality stuff we did last week. So line 15 converts it, and it'll go from being a value to data, and now it's clickable. So now I can look at it. So it's 2 lines to import. You can't combine them together. I've tried that too. It doesn't work. But so you have to have both lines, and all you're really changing is the name of the file. Okay. So that's how you import SPSS files. So let's say you're working with Qualtrics, which is the survey software we have on campus, and you have the option to download it as one or the other. A couple of different ways to download. Always go with CSV if you can, because, for example, my friends' research that I work with them on, they have sometimes like 700 or 800 columns of data, which is a lot. And when we import it from SPSS, it pulls in those value labels. So they have Likert scale items where 1 is agree and 7 is strongly disagree, and it makes all of them factors, which is not what you want. And so you have to sit there and one at a time turn all of that off. So you have to go from a word column to a number column, and it's miserable, to put it nicely. So the nice thing about SPSS is it's more visual than R. The bad thing is it takes over control for you. So there are a lot of things that you just literally cannot do because they won't let you, or the math is wrong, or it's so obtuse that you can't figure it out in SPSS. So this gives you more control with R. And you can import SPSS files. I just try to avoid it if you can as well. But here's how. So when your advisor gives you something in SPSS, you can still use it. All right. The next thing we're going to do is factor functions. And so to do that, we're going to make some fake data. So the repeat function, which will repeat 1 through 3 50 times. So that was part of the videos. And I want to factor that. So I want to give it labels and make it into a variable that indicates that this is groups or categories. So factor variables are really helpful, and Ggplot really requires sometimes for you to use factor labels. So I'm going to make my first fake data. Oh, if your data imports, this is a reminder, 17 through 21. I forgot that was in there. So if your column imports with a funky symbol, we did that a couple of weeks ago, but here's just a quick reminder of like how to fix the symbols, because that might happen to you here in a minute. All right. So I'm on line 25, and so I'm making my fake factor. So that's a little bit of review from what we did last week, but now I've got here an integer, so it says int here, 1, 2, 3, 1, 2, 3, 1, 2, 3. Instead, I want that to have labels about cheese, because of course. Here's the deal. For the factor function, which is where we're going, it's line 27, you really have to know what's in the data. Let me make this bigger. There, that's a little better. Okay. And that's what this warning is. So check and see what's in the data. Don't assume that it's 1, 2, 3. Sometimes it's 0 and 1. And sometimes randomly your friends label things 0, 1, 2, and 7 and 9. And you're like, okay, why? But don't assume you know what's in the column. Okay. So I'm going to use that table function to see what's in there. Okay. So the table function tells me I have 51s, 52s, 53s, but I know it's 1, 2, 3 here. Don't use summary. Summary would give me an average. That's not what I want. Okay. Let me show you on the slide here. Now that I know what's in there, I can factor it. Okay, so what factoring does is it adds labels. So it's going to convert this from a number column to a labeled column. And labeled columns do different things. So remember, we talked about string columns versus numeric columns. These are factors, which is like a string and a number at the same time. So the function is factor. The name of the column. So in our example, it's not factor. If it was in a data set, it would be dataset name, $, column name, comma. The levels here, so there's no dash, this is just PowerPoint, but levels equals, that's where the table function is important. So the levels have to be whatever is actually in the data. And in this data set, it's 1, 2, 3. If you stick something in there that doesn't exist in the data, it will make you a fake factor for labels that don't exist. And then it deletes all the other ones. So if your data set was 1, 2, 3, and you put in that it was 0, 1, 2, it would delete 3. Deuces. That's handy sometimes, where you can get rid of things that you don't want. So like participants who, let's say you had male, female, and other, and you don't have enough others, and you want to drop them temporarily, you can actually use factor to delete that. Anyway, and then the labels. The labels are you type them. Girl, boy, geez. The labels will get added in the same order as the levels. So if you do 1, 2, 3, be sure you put your labels in 1, 2, 3 order. This is normally fine for people until we get to a column where you're wanting to relabel them. So let's say you have a column of data that's already been labeled, but you labeled it male and female, because I do this all the time. I don't know why. Homophones. Okay. And I'm like, oh, right. This time, I would have to do something like this. So I would do factor, the name of the column. It's already factored. So here under levels, I've got to type it exactly how it's spelled. Spelled? Spelled. Oh my goodness. It's Monday. Okay. Caps matter. Okay. So I would have to write this, or type it, rather, exactly how it already looks. So that's why we ran table first. Then I could fix it. Then I could find a marker that works. So now I can label it. And that becomes useful when you want to respell or make them more formal. So a lot of what we're going to talk about today is making graphs look nice and formal. This is a way to fix the way the labels look. Okay, what do people do wrong? They type in the wrong levels in the middle, and it eats half your data. It's the most common mistake. All right, so I'm going to run line 27 through 29. So kind of back to Adam's question about what are the pluses. Same idea. The lines end in a comma. So if I were typing this out for real, let's say I just wanted to type it. Okay, and I did not factor, and I hit comma. If I hit enter here, it automatically stacks it for me. So this is what I mean about stacking. So after that comma, I just hit enter. And it knows, okay, we got a comma, so something else is coming. So I'm going to move it over here because this is still part of the previous line. Okay. If you do it in a weird spot, let's see here. Well, okay, it auto-filled that in. It's still going to kind of stack it for you, but there's no comma here. If there's nothing, if the line isn't in with a plus or a comma, R is going to think you're done and give you an error. Okay, so one of the more common mistakes is people don't have their lines ending with the right type of thing to indicate there's another line coming. Okay, that's really easy to troubleshoot if you have it stacked. because that's the first thing I look for is the end of line codes. All right, so let me get rid of that because that is not what we want to do. All right, so I'm going to run 28. Oh, hopefully my numbers are still the same. Those 3 lines together. As you do that, watch what happens down here. So it gave me the little greater than sign, and then a plus and a plus. So that meant that it knew that there was more coming. So this is all 3 lines together. So that's part of the pluses. Now I have my caret back, my greater than sign, so it's like done with me. If you do this right, you won't get an error and it won't look like anything happened. So we're going to rerun that table function, and you should now see a variable called factor. I renamed it, and it's got labels on it. One second. Yes, I can in just 2 seconds. And then over here in the environment window, you should also see the difference. So this one says integer, this one says factor. Yes? The second one is labels. Labels and then labels. So that's okay. And I have this code on mine if you want to open it. Because once we get to the plots, it becomes too much to type. Okay. Other people, nobody else has barked yet, which is good. Okay. The factor function is something you will use hundreds of times. Back me up here, Flora. You have hundreds of times. Yeah, she's like, yeah. But no, you will. We're going to use it 5 or 6 times in the rest of this lecture. All right, it's really handy. Once you get the hang of it, it's really useful at helping you make things look pretty, dropping columns you weren't interested in, and using them for all of the ANOVA section. All right, so let me talk about wide to long. So we've installed the Reshape package and hope everybody's got the library loaded. We're going to load this Gemini cricket data. It says it all from the book. And you should be able to see the data because there's a summary function. And we're also going to look at the data like in a picture. Nope, pictures later. JK. Okay. So we're going to load this cricket data. And I'm going to get a summary here. Okay. So you'll see that mine has done that double I umlaut thing. So if yours has done that, you will want to fix it. Okay. So to fix that, call names, cricket. If yours didn't do that, you don't have to do this. Oops. Quotes. Oop, nope, cancel. What are you doing? What's happening? Not what I wanted. Okay, thank you for installing Ggplot. It's running my entire thing. There we go. There we go. That was fun, but let's not do that again. Okay, so my cricket data should look like this. And I'm gonna run the summary again. So you shouldn't have this like I double dot thing, or this next line's not gonna work. So it's call names cricket. So that's the name of the data set. Square brackets for first column, and I called it ID in caps. That's a Mac to Windows problem. So if you're on a Mac, it probably won't give you that problem. It's like the one good time, right? Okay, so to kind of talk about wide versus long format. So I'm going to look at my cricket data over here. This is in wide format. Wide format is like the way that we're used to thinking about it, especially if you've used SPSS, where each person gets their own row. And it's one person's data all the way across. That is fine until you try to run an analysis with a repeated measures design. Okay? So we've got this success pre and post. And so pre-post is repeated measures. And R does not like it being all one giant line. Sometimes you can get away with it, mostly you can't. So it's in wide format. So each row is its own participant, each column is a variable. And this sort of way, there's more ways to do this. We're going to call this long format, where each variable is its own, like each time point is its own row. So this is especially important with repeated measures data. Excuse me. Okay. So each row is its own participant. I'm sorry, each row is its own time point by participant. And that'll be a little bit clearer once we actually run this. So we're going to use, this is what Reshape does. So this is why the Reshape package. To go from wide format, which is generally how you get data, to long format, it's melt. So we're going to melt the data. This is like some kind of D&D joke. I don't understand. But from long to wide is cast. I have a little star there because I'm not actually going to teach you cast because it's so rare that you would do this, and it is evil at best. It is like you would think they would kind of match each other, totally different monkeys. Every time I have to do cast, which has probably been once in the last 2 years, I've cursed long and hard and found someone else to show me how to do it. Okay. So I actually took that out. It's in last year's lecture, but we never used it. So we're just going to do melt to keep our brains moderately simple. Now the way melt works, and that's lowercase. I don't know why it's in uppercase. Okay. We're doing this on data frames, so we're taking the whole data set and converting it. So we're going to do data frame, comma, ID equals, so this is any type of variable you want to stay. So the first row is these variables stay. Don't do anything to them. So we don't want to change these variables. Those are usually participant IDs, gender, demographics that you don't want to move. They're going to get repeated though, because if I take participant 1 and make them 3 new lines, that stuff just gets repeated. And then measured equals, column, column, column. These are the ones that you want to combine to squish. And that's where your repeated measures variables go. Most common mistake here is spelling. So the column names have to match. Sometimes it'll run and do something weird and not give you an error. Most of the time it tells you something, column name cannot be found. Okay. So here's an example from today. So we've got our cricket data set. I'm going to save this as long cricket. Okay. And that's something you'll see me do a lot. If it's a long data set, and I have the wide version too, I always call it long and then the name of the data. So I'm going to melt cricket. My 2 columns I want to stay the same, and then my measured columns that I want to change. All right, and that is here. And that's why I said you've got to fix the column name problem, because otherwise here it would have a fit. Now, nothing happened. It should have a new data set over here called long cricket. And so what you'll see is that it is 500 rows. So I can see that here, 500 rows, or here, 500 rows. Whereas my cricket data is 250. Because it essentially took pre and post and just did this with them. So we went from here to here. This is like airport signaling. If you want to see this even better, when you have long cricket up, click on the ID column to sort by ID. So you can see that each person has 2 rows. First person, pre-test score, value. First person, post-test score, value. So it's just taken that second column and stuck it underneath. So a couple comments on wide to long, so melt. You don't actually have to have any IDs. So let's say it's all repeated measures. We have an example here in a little bit where I have just all repeats. And there's no ID column. You can actually leave that out. It just gives you this one little warning. It says using ID as, and then there's just nothing. Okay, it's not broken. It's just the way it handles the fact that you left that blank. That's the first one. The second issue with Reshape is that it always calls the columns variable and value, which is useless. So using things that are named appropriately, but you'll see under long cricket here, it's named that variable is the one that has the names of the columns, value is the number. So later we're going to talk about how to rename those. It's the call names function, again, just slightly differently, but into something more useful, like time, pre and post is time, right? Score, those would be more useful names. Okay. But it always calls them variable and value. Nothing yet. Okay. So, why it's long.
Wait, so if you don't have an ID,
Hmm?
you don't have an ID for it, how does it aggregate the data into like who's a 1 and who's a 2?
It doesn't. Sometimes it doesn't matter.
Okay, yeah.
So like when I'm making a plot, I'm creating the averages of that plot anyway. But when you go to say run the real repeated measures ANOVA or dependent t-test, it does matter. So we'll talk about how you add the ID first and then multiply. Okay, so let me talk a little bit about like graphs in general, just some like thoughts on graphs. Oh, I took out box plots. Oops, I forgot to fix that slide. And then we'll take a break. So this is just lecture stuff. So this is chapter 4. It's all about making graphs. So Ggplot is going to seem like a lot. Just kind of warning you. I'm not saying that you're not going to get it. It's just, it's a lot at once. And we will try to ease frustration as much as possible. But what I have is I have this file. Actually, I use this file. Anytime I have to make a plot, I literally open this file for my notes, copy the plot that I'm interested in, and then edit it. So hang on to this kind of code so that you don't have to recreate it from memory, because I can barely even do that. Okay. But the nice thing about Ggplot is it gives you a lot of control over all these different pieces of the graph. So you can make them pink and purple and green if you want. But on the homework in the lab, you have to prove to me that you know how to make them pink and purple and green. Does that make sense? So you'll lose points if your x-axis label, we're really picky, isn't proper case. And by that I mean like each letter is capitalized. Or if you don't clean up the graph. And we'll get to what that means. Anyways, so graphs in general, we're going to do histograms, nix the box plots because we don't tend to use those in psychology very often. We're going to do error bar charts. So this is your traditional bar graph, scatter plots, and line graphs. And I tried to hit an example of each of the different types of issues or problems that you might run into. Okay, like the no ID thing. All right, so graphs should show the data, should not obfuscate the data. Like I want to be able to ignore that you've even written words and see a graph and see what happened in your study. Because that's easier than reading all the like crap statistics in it, right? But it really should be, I should be able to look at a graph and look at the data and not spend my time trying to figure out what the hell is going on. Okay. So I knew I had done something right in my life when we were sitting at a talk with a big name person and they were yapping. And I was sitting there looking at our slides like, what every grad student must have made, every like different student must have made these slides because every slide was a different theme and like clearly different people had put it together. So like trying to figure out what's going on. And we're sitting there looking, and the person sitting next to me, one of my students, was like, what is that y-axis? And the other one was like, where are her error bars? I was like, yes, I've done something right. Because those are big things that we're going to talk about. But it shouldn't, the graph shouldn't be confusing. The labels should be clear. It shouldn't lie with the data, and it shouldn't hide the data. So we're not going to distort the data, although we'll talk about how you can distort in the way to talk about how you don't distort. Present many numbers with many means. I don't even know what that technically means, but like lots of means without it being a whole bunch of text. Making large data coherent. And so I sort of love the last one, should reveal the data, like it's like the Wizard of Oz. Okay. So some examples of some bad graphs. Okay, so some old school graphs. I don't think you can even make these in R. But they look like pencils to me. But one issue, especially with 3D graphs, is that it's hard to tell what's actually going on. Okay. While this does have labels, one of them is variable, and the other one is number, which you probably can't read because it's really crappy text. But what does that even mean, variable and number? What are these bars? So it says the 95% confidence interval, but I couldn't even tell you what the mean is because it's hard to line it up. Okay. So it's a bad graph for a lot of reasons. So 3D charts tend to be unreadable, depends. You don't tend to want to use patterns unless you have a really complicated chart and that's your only option. Bars, cylindrical bars are not easy to read, bad axis labels, and overlays. So try not to overlay data. Okay, with the exception of scatterplots, because you don't have a choice. Instead, it should be more something like this. Now it makes more sense. So the therapy type, number of obsessive thoughts per day, so the labels got a lot better. And now I can compare and see that this mean is probably 13. The only problem I have with this graph is that I can't see both ends of the confidence interval. It'd be better if I could see both. So, cleaned up graphs. We're trying to make these types of graphs. The other thing that we can do is deceive the reader, and this is actually a joke from the book about cheese. It's not actually my cheese joke, but I find it funny because I've always made cheese jokes, and then when I was reading this book, I was like, yes, we're separated at birth. We both love booze and cheese. Right? So it's unreadable because the copy from the book is just bad. But the issue is about the y-axis here. So one thing especially politicians love to do is to stretch the y-axis. And what that does is it makes the difference between groups look a lot larger than it really is. And we're going to talk about how you are supposed to do that. That y-axis should be the scale of the data. So if you have a 1 to 7 scale and the y-axis only shows you 5 to 6, you're distorting it. So stretching the y-axis is a big problem. It's really easy to do, unfortunately. So we'll talk about how to fix it. Okay, so don't distort the scale of the data. All right, so to do this, we're going to install Ggplot2, which if you are on the computer, you did your lab last week, that was one of the things in the lab. But try installing it and loading it so we can fix all the problems we're probably going to have with it before we get started. And then we're also going to take a short mental break. Okay, so we've all got it installed, hopefully. So here's how Ggplot works. And this is a conceptual thing that takes a little bit of getting used to. But the first thing we're going to do is run a line of code that tells it what to use. So here are the variables we're going to use in this graph. Okay, and that's generally this. Then the next thing you do is you add pieces to it. So I've got my basic graph plus bars, plus error bars, plus axis labels. So each one of these pieces gets added like a transparency. So they're added layer on top of layer. Are we so far past anyone ever using transparencies that doesn't make sense yet? Okay. So it looks like a lot of code, but that's because each little block, little piece, is adding another piece to it. So I love Ggplot because it's got a zillion options, and it's not like I'm like in Excel like trying to move the stupid bar around and like trying to remember which version of Word it is. So how do I add the error bars in this? So it gives you a lot of control. But at the beginning, I will tell you, it's a little overwhelming because it's just a lot of code at once. Okay. Which is why we gave you all the code. I gave you all the code. I'm telling you, cut and paste. You need a scatterplot, go to the section of the scatterplot, paste it, change the code for what you need it for. The book section is 432, and it has a reference chart of a bunch of different things for Ggplot. If you get totally stuck, you can also Google it, and usually you'll find something on Stack Overflow that might help. Or you can ask one of the 3 people for this to help with this class. Okay. So, kind of going over, but now this time with code. So first we're going to define the structure of the plot. So with each one of these plots, hey, plots. Okay. So with each one of these plots, it's got this AES thing, okay, this aesthetic. If you look at the code, I have like a line right underneath the plot that says what you should use for aesthetics, and that'll make more sense in a second. So my graph is Ggplot, so that's the function name, the name of the data set you're pulling this from. Okay, so it has to be in a data set or it doesn't tend to work. AES for aesthetics is what that stands for, which I think of that as like which one's X, which one's Y. So X always goes first. So some column for your x-axis, some column for your y-axis, and then options for adding multiple variables. Color/fill, it depends on which graph, which one you use. Sometimes one, sometimes both. Okay, it depends. So that's the basic idea overall. But if I save that sort of graph, nothing happens. Okay? So it'll tell it, make this graph, and we'll try this in a second, and you run it. Literally, it just gives you a blank plot. So the rest of the code that looks kind of nasty is all the different layers. So we're going to add bars or dots or a line or labels. So here's an example of one. You wouldn't do this, actually. This is just an example. So this answers Adam's plus question. So I want to take the original graph already defined, add bars, add points, add labels. So the last line won't have a plus. Okay, yeah.
And is that where you like, so if you want the whole label capitalized, you just have to capitalize it all? And
yes. Yeah. So when we get to changing that's like the x-axis label, the big one. When we're getting into changing like the bar labels, that's a slightly different code. Okay. So I can either refactor it with nicer labels, like what I did on the board, or change them within the plot.
And so if you change it within the plot, it doesn't change the factor?
Exactly. It only changes the plot. The advantage to doing it that way, instead of refactoring, is if you have just a whole lot of code that assumes that the name is this, and then later you can just change it for the graph. All right. So we're going to start with each one and then give you an example, because then the times that you use which function applies only to this type of graph. We've actually already done histograms, but now fancier histograms. So you guys kind of know this already, but a histogram, the x-axis is like some sort of continuous score. You don't really make histograms with categorical variables. And then a frequency is the y-axis. And so really they're useful for looking at skew, kurtosis, that's the shaped stuff, how far the spread is, or any type of unusual score. Okay, so if you have an outlier, that sort of thing. In general, this is a whole example, but if I'm making a histogram to just do data screening, I'm using the Hist function because there ain't no need to go through all this crap to make a histogram when I just want to look at it and not print it. This is like if you want to make a nice printable histogram, and it's an easier way into Ggplot. Okay, 'cause these are the easiest. All right, so that Gemini cricket data, which is witching up on a star. So we measured the success of 250 people before and after, and so we ranged their scores from 0 to 4, and they were told to either wish upon a star or work really hard. So silly example, but let's say we want to make a histogram of one of the either pre or post. Okay. So we have loaded this data. Unless you've had to restart, you may need to reload it, and let's build that plot. So I have here towards the bottom, just if you need to reload it, you can rerun that. Okay, so here's where I have the information about the aesthetic. So it's always right next to the plot. So for a histogram, aesthetic only has one variable. There's only one, because there is no y really. Y is frequency, it's set for you. So don't put 2 in there, because then it just is like a hot mess. So if you're making a histogram, it's dataset name, comma, AES, that stays the same, don't change that. This right here, whichever variable you're interested in. Okay, so we're going to do pretest scores. Okay, so all this line does, 56, is make me a blank plot. and I'll prove that to you. So run line, whatever, it should be close to 56 for you guys. And if I just type Cricut Hist at the bottom, which is what I called it, over here, and run just Cricut Hist, just this word, you should get this, which is a blank plot. Not very helpful. But this is sort of trying to explain like how the transparency idea works. It's also a hideous blank plot. The x-axis label is not very good. I can't even see where 0 is. That gray background is the worst. I do not know why the default in Ggplot is to have a gray background, but it is. It's awful. So to get this, all I typed was Cricut Hist at the bottom. All right. So to build a histogram, we're going to add geom. So anytime you see geom, that's like telling it what to add. Dots, bars, lines, stands for a geometric object. Underscore, which is hard to tell because of the little underlines here, underscore histogram. So add a geometric object, add a histogram. So I'm just going to cut and paste this, stick it in here. I didn't run what's in here. This is like the final version in the notes here. So it tells me my stat bin is not very good, which is bin width. Okay, what bin width is like how big the bars are. And it's sort of backwards coded. You would think like bigger numbers would be bigger, but it doesn't quite work that way. But it'll give you an example. It says try use 30. But still an ugly histogram, right? At least now I have bars. It's a multimodal histogram, right? Got 3 or 4 good points. It looks like a castle, right? Disney castles. Okay, fine.
Why do we have to put it down there? Why couldn't we run it?
You can run at the top, but what I have right here is like the final version, and I'm trying to do one piece at a time.
Okay.
Which is what this has. So we could change the bin width. I always just like pick a number and see what happens, because I can never remember how this is coded. See what happens. So 0.4 makes them really tiny. Probably not what I wanted to do. So I could try going the other way. Make it 10. And that makes them really large. So I was just kind of like mess with it until it looks better. So this is one way to cheat, is to change the bin width in an appropriate fashion. So 30, which is what it suggested we start with, is probably really not good. Probably is just one giant bar. Yeah. Okay. I tend to stick with small bin widths. Okay, small hovering 1 to 5. It depends on the scale of the data too, so that's why I don't have a good recommendation. I always just kind of pick a number and start, see what happens. So there's no hard and fast rule for bin width. In bin width, you can also, I'm sorry, not in bin width, sorry. In geom histogram here, I can also change the color. You can spell things British style or English style, and sometimes it mixes and matches in the notes, and that's because the book is written by a British dude. So anytime you see color spelled with a U, that works fine. It also accepts both spellings of the word gray. So let's see here. I could make it color equals purple. Now what that did was it changed the outline of the bar. So color changes outlines, fill changes the inside. Okay. So you can make some really ugly ones. We're doing black and white. So that's why there's 2 different ones here. So the quick rule, and like I've taken a note somewhere because I don't think I have this written down, is color is the outline of the bar or the dot or the whatever. Okay. Fill is what the inside is filled in with. So all of the graphs I'm going to have in here are going to be in black and white. I said you can make them any color of the rainbow that you'd like. It accepts a lot of words like magenta. There are ways to do the color, like if you're good at web programming, HTML, it will take that too. But it accepts most words, like steel gray is one of them. There's a list somewhere of all the different words it takes. All right, so I can change the width of the bars, that's bin width, the color of the bars, and the fill of the bars. You notice how that's all here in your histogram. So because it's in the parentheses, I'm modifying the way the histogram looks. So that color and that fill are only being applied to the bars because it's part of that histogram option, which is why it is double stacked. It only applies to the histogram and not the labels or anything. Oop, too fast. And then the labels are thankfully pretty easy. X lab for X, Y lab for Y. Unfortunately, legend labels are the worst. So success pretest and frequency, because it's a histogram, the y-axis is always frequency. And you'll notice that each line ends with a comma or plus. Okay. If you leave one of those off, it will make you the graph and then be like, why do you want this next line? I thought we were done. All right, so if I run here from Cricket Hist and on, I should get a less ugly histogram. Word of warning. Let's say you're working with a graph and you're like, screwballs, I left off X, or I spelled something wrong. Okay. You do have to run the entire thing all together. So a common misconception is that I can run this Cricket word, oops, no, not backspace, run, and then I can just run the rest of the lines. That will not work. Okay. That's the one thing I think people struggle with sometimes is like, if I want to recreate the graph, I mess something up and I want to fix it, or just need to rerun it for whatever reason, you have to run the entire set. Okay. Not the first line. As long as that's there, that's fine. But everything from where it starts with the blank plot plus everything, you have to run the entire thing. It's very tempting to think like transparencies, I can just keep adding and typing and adding. No. That would be cool. It works in other places, but it does not work for this. So we've made our first graph in Ggplot. We've all survived. Yay! Let's get more complicated. We're going to try a different histogram. This is on festival data. So the health effects of not showering over a festival. For 0s, you smell like a corpse, and 4s, you smell like sweet roses. This is why I like the field book, because at least he tries to make things like histograms amusing. Okay. So we're going to create that plot. So let's load the data. It's this festival data. So you'll see another common thing is on the name of the data set plus what type of graph I'm making. So festival histogram. Just like we did long data set name, you'll see like something scatter so that you know what type of graph you're making. This is our blank plot, so Ggplot. Data set name, which is festival. Don't name these the same thing or it will blow up. So be sure these two things are different. Aesthetic, only one aesthetic, day 1. Day 1 is the name of the column in that data set. Okay, so day 1 here. Alright, then we've got the same code. So I edited the bin width, I think, was the only thing. So this is that same code. So geom histogram, give me a smaller bin width, make it black and white, give me some nice X and Y labels, and then here's the new thing. So theme BW, to put it in black and white. So if I run all of that, it makes it, this to me reminds me of like chemistry class with those lines. I don't know why. Little notebooks you would write in. So theme black and white here turns the background to white, it like inverts the graph basically, and adds like some axis lines. If only it were that easy. Now the nice thing about that is that we can see that there's an outlier. So one reason why the bin width was smaller was so that we could get everything on one screen. That little outlier, it's clear how far away they are. if you change the bin width, so let's make it like 20 or something. Okay, not as obvious. So that 0.4 I came up with just kind of trial and error. 1 still works okay. 0.4 gives me some more detail, more bars. Okay. And that might be a little too small. Okay. In general, the rule is you don't want too few bars or kind of a whole lot of bars. There's no, like I said, no hard and fast rule. Now, theme BW is really nice, but that is not publishable. Most people would say that's got too much superfluous stuff on it. Mainly that the backgrounds, let's say if you're talking about photocopying from a journal, that those gray lines get to be messy and you can't read what's going on. So instead I'm going to talk about this giant piece of thing right here. It looks really scary, but it's not. Okay, so quick rules. You have to have X and Y axis labels, so these are the things that we'll be looking for. No title. That's APA. There are not titles on graphs. They're in the figure captions. But I'm not even going to tell you how to add a title. So just don't do them. Labels for your groups or your legends, error bars when you need error bars, and they should all be readable. So proper case, this is like the biggest thing people do wrong. Proper case. Never know what I mean proper case? Each letter is capitalized. Right? Don't leave it the variable name. Capitalize things. Make them look nice. And then they shouldn't be ugly. And by ugly, I mean like, you can make them pink and purple, that's fine. And it says that in the homework. You can make this pink and purple, because then I know at least you know how to make it black and white by changing the colors. By ugly, I mean like you didn't try this next thing at all. And it's really not hard, because you just copy and paste it. All right, so let me tell you about all this stuff. I'm going to blow it up. Okay. So I call this cleanup. Sometimes you'll see me call it theme by accident, but back to don't name things the name of a function. So the function name is theme. So we're going to call this cleanup code because it's the cleanup crew. And you can just cut and paste this over and over again. Why should I separate it out? Why shouldn't I just add it to the end of the graph? Well, if you're making 3 or 4 graphs, at least you have that saved as something else. And so you can just type cleanup and you don't have to cut and paste that giant thing over and over again. All right, here, panels grid major is the major graph lines. Element blank, turn them off. Panel grid minor is the little minor gray dotted lines. Turn those off. Panel background is the background. Turn that off. So element blank is like off, off, off. X-axis dot line dot x. That's add a line at the bottom of x, which is normal for our types of graphs, and make that line black. Okay, x-axis line dot y, add a y-axis line, so we're going to have x and y. Legend.key, turn off the fill. So annoyingly, you can turn off the background and make it white, but then the legend turns out gray. Useless. So that's how you turn off the gray legend. And element text size just makes the text font bigger. It's a little easier to read. And so all these taken together are like accumulation of like making plots for actual publications of the things that make it look presentable. And the nice thing is you run this once, you add it to your graph, and it cleans everything up for you. All right, so before I get to scatterplots, let's try that. So I'm going to run all this. Now, on its own, it doesn't do anything. It's just one more thing I can add to my graph. So around line 83, I have that same festival graph, but now I've done plus cleanup. Okay, so it's the exact same graph from above, but no black and white this time. And look how much nicer it looks. So the font is larger. Right. I've got X and Y labels, no background, no dots. If you want to see a previous plot, here under plots, hit the back arrow, and you can kind of flip back and forth. So it's just easier to read. Okay. This also gives you control of how long the y-axis is, but we're not going to do that quite yet. So that cleanup code is in the rest of these graphs, all of the rest of them. So I only had to copy it once. The problem with that is, let's say you're working on an assignment. If you don't run the cleanup code that's up here, it's not going to do anything down here. So you do still have to remember to run it. You'll get a little error, cleanup not found. That means you forgot to run that block of code. And it might even help if you just did like a separate section so you can find it again later. This is where the cleanup mess is. Okay. So let's try some scatter plots. So simple scatter plots have two continuous variables, x and y. Grouped scatter plots have two continuous variables and a legend, so some sort of categorical variable. So we're going to start with this anxiety data set where we have participants, and this is sort of funny, it's about exams. So time spent revising your exam performance, your exam anxiety, and gender. Now look at the relationship between some of these variables. See if we can make a scatter plot. However, once I import that data, I'll look at it over here on our exam. Gender is unfortunately only 1 and 2. That's not very helpful. Don't know which one's which. So I need to add the labels to that. It doesn't really matter so much that we have the double I code issue because we're not going to use that variable. But call names function will fix that. So we're going to factor. So this is why we started the lecture with factor. So I could run my table of the exam data set and gender. And that's how I know it's 1 and 2. So I want to overwrite the variable. The problem with overwriting the variable is if you screw this up, you do have to reload the data, but the line is literally one above it. Okay? So if you mistype something, it will overwrite in each your column. Just don't worry. Okay? So refactor my gender variable. I still want to use gender, so data set, column name. Levels, remember levels what's already in the data set, so it's 1 and 2. That's why I have 1 and 2. Labels, male and female. If you're doing this, go ahead and put it in proper case. Alright, so 1, 2, 3. Now if I do my table again, did you get it? Now I have male and female. Some not run. Right? It didn't run, or
It's giving me an error.
Okay.
I don't know, I probably missed this stuff.
I did try to drink from my Coke can the wrong way just now. So no, it's Monday. Where you at? Where you at?
Ooh. Nothing like that.
Uh-huh.
Yeah, that's scary.
Why did it sound like it?
Ooh, not properly, no.
For the last 3 weeks. Maybe I'm just honestly confident.
That time it did. I don't know why I didn't like this. Okay, now try it. 7 and 9. There we go.
Yeah.
Okay, I don't know why I did that. I'll see if I can find out why. So we can not do it again. Alright, so I've got it loaded, I've got it fixed. Let's try a scatter plot. Okay. So I've got my simple scatter plot here. And I've, again, tried to tell you what AES should be. It should be X, comma, Y. So I've got Ggplot, dataset name, aesthetic, X, comma, Y. And if you get a plot and you're like, ooh, that looks funny, try switching them. You might have them backwards. I have done that myself. Now, to add the dots, we're going to use geom_point. There's a different one called geom_dot. Don't do that. Very tempting. It's geom_point. And then I'm not going to put anything in point. You can change the color there. You can change the size. You can make them triangles instead of circles. But generally, we're just going to leave it alone. So geom_point. And then the same 3 we've been doing. xlab, ylab, xlab, ylab, copied from a previous slide. So that should say something more useful like exam anxiety and exam score. Eyeball. In here I have it correct. So we're making a scatter plot. If I run just the scatter plot, again I get a blank graph. So let's add things to it. So we're going to add points, X, Y labels, and clean this thing up. Now I have a very pretty graph. And it's curvilinear. So the nice thing about making scatter plots is that you can tell what the relationship is to the data. That's not going to be linear. So it's going to be curvilinear, looks like a bow and arrow. But as students get more anxious, exam scores drop, which is that U-shaped motivation curve stuff. But scatter plots, yeah, X lab, Y lab, cleanup, we did in the last one, so it's just an addition of G on point. So the nice thing about Ggplot is it repeats. So you're just telling it, okay, I still want my X and Y labels, but now instead of bars, I want points. Okay. All right, what if I want to add double sets of dots? So here's the graph. Oh no, sorry, we're going to do regression line first. So let's add a regression line. Point is the same, X lab, Y lab, cleanup, all the same. Here's the new one. Geom smooth. This does, to me, is like all I hear is Rob Thomas, right? Because I love Rob Thomas, but smooth is like a weird one. You would think it would be Geom line, it's not. And that's because what it's doing is it's calculating the regression line and it's smoothing it. So it's a whole set of functions, but it's Geom smooth. Now what this does is it makes it a linear model. So method equals LM is for linear models. That means the line's going to be straight. If you leave that out, it will give you a curvy line. Okay. Color changes the color. So you can make it green if you want it to. So let's try that. That's here around 108-ish. So I can tell, okay, it made me a linear graph, but I'm not capturing this half of the dot. But what are these gray bars? Okay. So give me this weird gray stuff. And that's the 95% confidence interval for that area. Okay, so this is a really popular trend to include regression lines that show you how much you should believe the regression at any given point. So it's a 95% confidence interval for each point on the regression. Which means over here, we're not as confident because it's a wider interval. Okay. Down here, we're more confident. Okay. We're not doing very good, but we're confident that we're not doing very good because there's a lot of dots. Okay. Down here, we're doing fine, but we're not so confident. So it's usually wider bars where there are less dots, skinnier bars where there are more dots, which is power. Right? And as you have more people, confidence intervals get smaller because of standard error, right? Because it's 1 over n. So just a refresher from 2 weeks ago. If you want to change the color of the confidence intervals, it's fill. So you could do fill equals. Okay. So again, color is the line, fill is the shape color. And you can even change the color of the points. This is going to be really ugly here in a second. So I can make my points purple. You can make them dots or triangles or pluses. You can do a lot of different things. Okay. Now, look, pretty graph. On to multiple group scatter plots. This to me is really nice. So let's say you have two different, in this example, gender, but I have two different groups and I want to see if their correlation is different. Well, we're going to cover how to do that later, like statistically, but on a graph. Can I make it visual where I can see that this group is positive and this group is negative? Or that this group has no correlation and this group has a nice correlation, okay, which is interactions in regression. That doesn't happen here. So all the magic actually happens up here. So this is the same. what we've done now is we've got dataset name, AES, X, Y, and then color and fill. This is one of the only times it's both. So what happens, so group scatter plot, it has X and Y, and color and fill are the legend. Don't do them as different things because it'll freak out. So I want to color the dots based on gender, and I want to change the line color based on gender. That's what you're telling me. Okay. Everything else stays the same. Okay, until we get down to here. We'll talk about that one in a second. So let me try running just to the cleanup. So it changed the, it picked the colors for me. I didn't tell it what colors to use, so it just picks, it automatically picks red and blue as the default. And it made the legend match here. But let's say I don't want to use that legend, and I don't like these colors. If I wanted more control, this is where it gets unfortunate. I have a slide on this. Okay, so the way I control the legend is either through scale fill manual or scale color manual. So in that first line of code, let me back up. Here, the way I built the plot, it says either color or fill or both. Okay, so I've got both here. And that is what happens at the scale level. So don't say colors, gender, and then do scale fill manual, because it goes, you don't have a fill, whatever, I'm going to ignore you. I wish it actually said that, that would make more sense, but it just ignores your code. So I'm using both of them, so this answer here, because I have both in my plot. If you were to only change one of them, I'll show you what happens, and you'll know that you've changed the wrong one. So the way this works, anytime you see the word manual here, it gives you all the control. Okay, there are a couple of options of scale something. But when you have manual, you have to give it colors. That's mainly what you're changing. So I have the name. Name is the label of the legend, so gender. Labels is the actual labels. So this is where I can change them to say, instead of male and female, I can say men and women. And then values are colors. So I can make it black and gray. If you leave out values, it will not run. If you leave out names or labels, it'll do whatever it wants, but values is required. So let me show you if I change. Okay, so here's the graph we're currently working on. This is the default. I haven't changed any of the colors. Let me just run scale fill. Okay, so I'm not going to include the scale color, even though I have told it fill and color. It makes you two legends, because you only changed one, so it's going to include the other legend because you need that information. So why both? Because you don't want two legends. It looks dumb. So if you have both of them up here, color and fill, you have to have both of them down here, and they have to be exactly the same, or you get two legends. Okay. So by the same, I mean the labels and stuff. Clearly I changed the colors here between the two, but if I had one of them spelled min and one of them spelled man, it would give me two legends. Do that. Okay. So the labels and the names have to match. But I changed the colors so I would have some distinguishing difference between the two. Otherwise, all black and gray gets a little hard to see. So everything purple is women with the light gray. Everything black and darker is men. And they're pretty much the same. So men and women have the same correlation, albeit poor correlation, between anxiety and exams. Okay. You'll notice that the confidence band got bigger. That's because we split the groups in half. So we have less in. So the confidence interval is a little wider because each group individually I'm not quite as sure. All right, those are just neat. I don't ever get to use them very often, but I like the idea of them. And then what that leads us into is bar charts. So generally in bar graphs, if you have just one variable, it's kind of a boring bar graph. So generally you have two variables. So that's kind of why we started with scatterplots, is that when you have x, y, and a grouping variable, it creates a legend. Bar charts pretty much always have legends. So now you've kind of got a preview on how to fix the legend. So for bar charts, usually it's the mean score and an error bar. Error bars can be confidence intervals, 95%, a standard deviation, a standard error, 2 standard deviations, 2 standard errors. There's lots of variations on a theme. We're going to do confidence intervals. So everything from here out is confidence interval bars, because that matches what this is. Okay, so pretty much everything like with a band around it or error bars is a confidence interval. That's a very easy question that you shouldn't miss. They're confidence intervals. All right. So this is the chick flick data. So we gave participants fake made-up data included men and women, and then they were either watching Bridget Jones's Diary, which is now relevant since they're about to have another movie, and Memento, and we measured their physiological arousal of how much they enjoyed the film. So could be hand sweat, could be just heartbeat. We measured it somehow. So this is the chick flick data. You have to have your categorical variable as a factor, or it will not run a bar chart. It will make you a scatter plot. It will not make you a bar chart. Okay, so that's why we started with learn how to factor. And the error message it gives you is really weird. I can't remember what it is, but it does not use the word, hey, factor this, you idiot, which would be helpful. But it's a weird error. Or it used to not. Ggplot is updated. It used to not tell you these. Anyways, okay, let's try one in variable. So chick bar, I've got my data set name, x, which is going to be categorical, and y, which is going to be continuous. Continuous is the word. So I've got that here, where it says the aesthetic is x categorical, y continuous. Don't flip those. You'll get a crazy graph. It'll probably give you an error and like a weird dot, like the plot will just kind of freak out. All right, so we're going to run this. We're going to import the data and factor everything so we can use it. Got to import it first. Ooh, grumpy, grumpy. I got the error you got. Oh, okay. So my data set, when I imported it, so I clicked on chick to look at it, it has that I, that double umlaut I thing, so it did not want to factor this variable because it's not a thing it knows. So I'm going to fix mine. It's like I can't fix this. Now that should work. Okay. So let me show you a mistake that is easy to make, especially when you get to running a lot of code. So mine only half ran. So I'm like, damn it, now I gotta fix it. And this film variable did run. So if I'm not paying attention, and I do this all the time, so guilty, and I rerun this film thing again, what's gonna happen is it's gonna eat the variable because it thinks the levels are 1 and 2, and at the moment, they're not 1 and 2 anymore. So I'm going to rerun it, and it's going to give me a whole bunch of NAs. So this is what I mean, like if you don't use the labels that are in there, it eats it. It doesn't even give you an error, it just goes, okay, I guess you didn't want that. So that's why you have this sort of data set is right here at the top. Okay, I'm just going to reopen the data. Okay, it's back to 1 and 2, and now I can run them once. Okay. And now they should be fixed. So if you get an error, what did it tell me? Replacement has 0 rows, data has 40 errors. It's something like this doesn't exist. That's probably one of those problems. It's spelled wrong or you've erased all the data. All right, back to the actual bar chart. So here's my bar chart. I've got the data set name, X, which is categorical, my film, Y, which is arousal, which is continuous, here. If you flip those, it will try to make you one bar for every single arousal number, and then Y will be categorical, and it looks just really strange. It doesn't know what to do. Now if I look at the blank plot for that, it's got my two nice labels here. X is not pretty, but I can fix that. So I can tell that it's split them into 2 bars. Now, in a perfect world, this would be G on bar. G on bar is a thing, not what we're going to do. Because we've done G on point, G on histogram. It's stat summary. So what G on bar would do is if you already have the means somewhere, it would just grab those means for you. That's not very helpful because then the error bars, I have to do something else for those. What stat summary does is it takes the entire data set and calculates the mean for you. So if you wanted to use G on bar and G on error bar, you pre-calculate. That's an extra step I don't want. So instead I'm going to use stat summary and it'll calculate for me. Now with stat summary here, the only thing that you'll really want to change is if you decide to make these goofy colors. None of this changes. Function of Y equals mean, that's calculate the mean. Geom equals bar, that gives me a bar instead of a dot or a triangle or something. Fill equals white, color equals black, we already talked about what those do. But this you just cut and paste. It doesn't matter what the variable names are. So those don't change. To get the error bars, it's a different stat summary. So function of the data is mean CL normal. So give me a confidence limit based on the normal distribution. Geom is now error bar. That gives you the little whiskers plot. Like this. This kind of error bar. Now, if you don't do anything else and you stop there, it gives you these ridiculous error bars that look like this. They're the same width as the bar, and they look ridiculous. So what position does is it controls where the error bar is. So position dodge means not on top of each other. So dodge meaning don't get hit. Width equals 0.9. 0.9 because it works. You can play with it, see which one you like. And then width equals 0.2 controls this width. Okay. So the first one here, position dodge, controls where on the bar it goes. So it might be here otherwise.
Is there any reason to do that?
Usually it's in the center. That's the most common. And that 0.9, it's like puts it there. But if you want to try playing, like just changing them to see like what it's doing, that helps sometimes if you're like, why is it this? These numbers just work. Width equals 0.2 makes it kind of a smaller size. All right, so let's try running that. So I'm going to run to here. You can run the whole shebang if you want. You jerk. Oops. Sorry, my Hmisc package did not get installed.
Yeah, mine didn't either, and it's huge.
Hmisc, yeah. So if you don't get error bars, it's because Hmisc didn't get installed. Oh, good gravy. Normally, when you open, if you have Hmisc already and Ggplots on your computer, it will open together. But mine did not. Yeah, but since you're working on your own computer, next time you won't have to do that.
That was another question I had with the cleanup.
Hmm?
Do we have to set the cleanup every time?
Yes,
Okay.
because it's not internal to R, it's just code. But that's why I always put it kind of at the top. I always just try to remember to run it. Like I usually stick it next to packages, because if I don't open Ggplot, nothing's going to happen anyway, so it's kind of normally where I put it. Right now it's kind of in the middle because it was like that point in the lecture. I'm like, God, this package. trying to think of some other things that happen. Oh, and I showed you the wrong position dodge stuff. Yeah, that's for double bar charts. I just realized they were different. For single bar charts, width, it's still the same width, but it doesn't have this extra position dodge thing. In a double bar chart, you're dealing with two sets of bars, so you have to tell it a little bit extra code. Otherwise, they end up on top of each other. So that's why dodge is important.
Oh no. It says our session was terminated.
Alright, so while we wait, I did show you the wrong one here. It's 4 in the next graph. But instead we'll do Giamma's error bar, width equals 0.2. So there's only one set of bars. My fault, sorry. Here we're going to talk about scale X discrete. So we did scale, fill, manual, right? Scale, color manual, scale X discrete. So X is a discrete variable right now, right? It's a factored variable. So that's hence why the discrete. I could do scale X manual, but then I would have to tell it the color, and I don't really want to mess with that. So scale X discrete only really requires labels. So this is the way they can control just the labels and screw the rest. If you wanted to do labels and colors, that would be manual. Yeah, so I left a note on why. So labels equals, and I could change the labels to girl film and guy film if I wanted. So, like what Adam said at the beginning, that will not change the data set, it only changes the graph. Now back to your question on what it does. The position dodge thing allows them to not overlap each other, and the width is controlling how wide this is. And then maybe Hmisc will have finished its mess. No, not today. So there's not a whole lot I can do until this is done. Good grief. Can't tell if that's Cran getting mad at us or the school internet. Alright, so we ended here on one independent variable bar charts where Hmisc was having trouble. So we've got our error bars, our nicely formatted labels for X and the X-axis, and a nice Y-axis. And we were moving on to two independent variables. This is very similar to how you do a grouped scatter plot. Now, in a grouped scatter plot, we had to use color and fill. Right? In two independent variable bar chart, it's just fill. Okay? So there's no color. So we have our stat summary. And I was going to work on fixing the notes, a couple little typos about stat summary. This one does have these extra position pieces. On the single bar chart, the dodge thing didn't seem to matter too much, but here it definitely does. So we can try it without dodge, and I'll show you what happens. Width is when we're controlling the width of the bar. And we've got our X label, our Y label, our cleanup. So if you're starting in the middle of your code, because we didn't finish last time, make sure you run the cleanup lines, or that is not going to work. Scale fill manual, what we did with our graphs, our scatterplot graphs, and names, labels, and values. Okay. So let's try that. We should get this. Fingers crossed. Okay. So the only bad thing about using black is that I can't see the other half of the error bar. So sometimes you may not want to use, you could use white and gray, would also work. The problem with using white sometimes is that it looks like it's not there. So you kind of have to manipulate colors, but for us, as long as it is not the default colors that R uses, and you can show that you've at least tried to do some of the colors, that's fine.
Is mine a color issue?
Yours, a color issue. Are you doing this one?
No,
The first one?
the second one.
No. second one? It only gives you one variable.
Yeah.
Oh, did you import the data set?
The two independent. No, it's I left it on from when we ran it last time.
Probably because gender is wrong as well. Could you hit the drop down on check data? Let me check. Where's check up here? So, okay, click on the down arrow next to check for me. Oh, that works too. Oh, it has to be factored. So gender has to say male and female. It won't run. Ggplot really likes factored bar graph variables. So this is around line 155, give or take. So it says aesthetic X has to be categorical. It does have to be factored. So that's the problem Adam was just asking about. Y should be continuous, and the fill also has to be factored. So just a reminder from Monday, under next to Ggplot, the first thing is the dataset name. Under aesthetics, it's X, Y, and then legend. So I'm just going to run the whole thing, and then we'll try it without some of this. So this is what you should get. Okay. But let's say we left off this position dodge thing. Right. So if I didn't include that, what happens? Which is a good way to learn like what the things do. That's where position dodge is important. So it's not, maybe it didn't need to be there for single bar graphs, but for double bar graphs, otherwise they like stack up here in the middle. Okay. So dodge means move them over. Yeah.
I just want to make sure I'm understanding right. Okay, so we can only use these error bars because we have more than 30 people in this, right?
No.
No.
Error bars are calculated based on sample size, and the larger the sample size, the smaller the error usually is, right? Because it's divided by the square root of n.
It's not, but we're not using the standard error.
It is. It's a confidence interval, so it's basically 2 times the standard error.
But I thought we could only use that for, because isn't that like the sample mean thing? No.
Say it again a different way.
So I thought if we were doing like the sample means and the standard error, that was like
our estimate of population.
Yeah, which we could only do if we had 30 more.
Oh, you're kind of mixing assumptions, which we're going to cover next week, with you can calculate a confidence interval on anything. Okay. If you have 30 people, that's where the central limit theorem kicks in, and the assumption of normality is assumed. I don't know how a better way to put that. Hold on to that thought, though, for next week.
Okay.
Yeah? Yeah.
Mine saying gender is not that.
Right. So when you imported the data, this is what I thought his problem was. You click here. See how it has that little double thing? Yeah, you can fix that first.
Do you know what line that's? I know it's supposed to be.
But it's just called chick. Oh, it's around line 21. Okay, now go down.
21.
Okay, now it's still not going to run.
It's saying
Because you have to factor it first.
Is not.
Here.
You gotta use chick data.
We are.
Not
Don't
chick.
run both. Ah, okay. Hit escape down here. Remember, because you run both, it's going to wipe it out. Escape down here. Sorry. Okay, so still there. Good. Now try your graph.
Just these.
No. Don't run those again.
Okay.
Now, sorry. Now try the graph. Graph, keep going. Okay, so that's one.
Run all of it.
Right here, too. Okay. So the data set is actually just called chicken. Good try. Wait, it's lowercase. And graphs. There you go.
Thank you.
Okay, what was the problem?
It usually is because here under chick, gender has the double I thing. The other problem could be that it's not factored.
Yours is factored.
What's the I thing? Where's that at? Like here in the name of the
The name of the column.
the name of the column.
Hers doesn't have the I thing in it, it's factored.
I have no idea. Wait, that's chick data. Here it's just called chick. So type the word data here. We imported it twice. Okay, that's data. Because I bet chick does have that problem.
Yeah, that's right.
Try running that with chick data, and it should work. Fingers crossed. That's graph. Graph.
It doesn't have the error bars, but it went.
Yeah, that's an Hmisc problem. I'll help you with it when we're done.
Okay.
Yeah. Right. Last two graphs. Okay. And then we'll try this on our own and hopefully it'll go a little smoother. So my quick warning that kind of matches everything that's happening right now because we had to take this break is at the top of whatever script you write, put what libraries you're using, right? So Ggplot, we're using Reshape, Hmisc, and then also any code that you need to have every time you run it. So importing the datasets or that cleanup code, because it's a little awkward right now. It's in the middle of the lecture, but that's because we hadn't gotten to it yet. But having all of that at the top, when you go to do this stuff on your own, you can be like, okay, I have to run all of this first, then all this code down here will work whatever order I do it in. And that'll help, I think. Because the problem is, it's like, okay, well, I have to run this and this and this for this thing to work. Does that make sense to people? Yeah? So a little bit of our trouble is like, oh, you didn't run this yet. So, especially if you get the error, such and such not found. All right, so back to line graphs. So when would I use a line graph? Line graphs are not the same thing as scatter plots with lines. Okay, we're treating those as different things. So a line graph is really for when x is categorical. It's a factor, but it's usually considered mildly continuous. So we're talking like dosages or time. So I barely use these, but it's a good reminder of how Reshape works. So it's usually run with repeated measures data, any kind of time thing, which is not how these examples go at all, but this is when I was just wanted to tell you, like, this is when you would use this. Okay. 90% of the time, we're going to do bar graphs instead of line graphs. Okay. So the silly example from the book is about hiccups. So we gave people who have hiccups, and we gave them 4 interventions, so this is repeated, and then we measured the number of hiccups they had. So lots of silliness to get rid of their hiccups. But the problem here is once we import this data set, is that it's in wide format. And Ggplot will not do this for you in wide format. So we need to melt the data into long format. Okay, so if your Reshape package is not open, you'll have to make sure that the library is open, or this won't run. So we need all the scores in one single column, and then a variable that tells it which bar or line to make. So that's melt. Okay. So the reminder of how melt works. So it's melt, right, is the function. Dataset name, measured equals. These are things that I want to melt together. So here's an example where we don't have an ID. And it'll run and it'll be fine. So let's try that. So first things first, under packages, make sure Reshape is on. Okay, so mine is not. I can't make that any bigger, sorry. So be sure you run either the line that opens the Reshape package or you click on it. If I can find. Do not do 2. I'm glad I heard you say that. Reshape 2 has the same functions, and it works in a completely different way. You will be sad kitty because it will not do what you think it should do. Okay, I also put it right here in the code, so we're on line 190-ish. Okay. Oh, 175-ish. Sorry, I can't read. Let's import that hiccups data and look at it. Okay. I don't have any problems with the double I thing. But if I did, this is where I'd want to fix it. Okay. So that's something you'll always kind of have to look for, is to make sure the variable name is imported correctly. Okay. So my hiccup data looks pretty good. And I don't know why. Sometimes it does it and sometimes it doesn't. If I knew why, I would never do it to you. So I don't know why it happens. So we're going to turn on the Reshape Library. And I'm melting the hiccup data set with my 4 repeated measures. You will get this little thing here at the bottom. It's red, but that's okay. It's not a warning, it's not a problem, it's just telling you something. Then if I click on long hiccups, I now see that it's giving me 2 columns instead of 4. So we've taken everything and squished it down. I've got the variable name and value. So remember, it always calls it variable and value, which is a little annoying. It should be like group, score. So what we're going to do is change their names. Okay, the call names function will be your friend because it allows you to change the names of columns pretty easily. It also allows you to fix the problem with importing incorrectly. So it's call names, data set name, and then now we're doing all of them, so there's no square brackets. And we're going to call it intervention type and hiccups. So I'm going to run that. And now under long hiccups, I have it called intervention and hiccups, okay, instead of variable and value. All right. We also need to make sure that the variable is a factor, but when you melt things, it automatically makes it a factor. So that helps, because otherwise it won't run. And so if I click on the down arrow next to long hiccups, it shows me factor of 4 levels. Right. To create the line graph, we're going to create our blank plot. This is first line. Data set name. Here under aesthetic, I have variable and value. And we've already done this. Making them make more sense. So 6 months from now, when your advisor's like, oh, hey, we got a revision on that. Can you fix all these things? Variable and value don't make sense anymore. So we're going to change them to intervention and hiccups. So that's what, this is the line that's in your script already. So it's data set name, X, comma, Y. The rest of the formatting is a little odd. It's not as long as bar graphs for some reason, but we've got function of y is mean, geom equals point, so instead of making bars, it makes points on the graph. This is the line, so function of y equals the mean, draw me a line this time. And this aesthetic thing has to stay. So if you don't have groups, if it's just one line, it's group equals 1. Okay, so what this does is it draws me 1 line. Then the error bar thing is approximately the same. So geom is error bar with no dodge on that one. X, Y, cleanup. All right, let's try it. Hopefully with no hiccups. Haha, I'm so funny. None of you laughed. Okay. So you should get this graph, unless you're having problems with the error bar thing, which I'll be fixing in a minute. So one thing it automatically does that I think is worth pointing out, but we're not really covering what we're doing with it yet, is that it automatically cut off the bottom of y. So 0 didn't exist. So it didn't start at 0. And you could say, well, that's stretching or distorting the axis. So instead, I'm going to make it 0, and we'll talk about how to do that a little bit, like in t-tests. But it made me a repeated measures graph. So everybody is at every time point. This is the geom dot thing, and then the line. The line thing just plays connect the dots. The scatter plots with regression lines create you the nice straight lines. This just plays connect the dots. All right, so that's this graph. One more graph. It's about text messaging. So does text messaging ruin your grammar? The answer is no. But we split people into 2 groups. Kids who could text message, kids who couldn't. We measured them at the start and 6 months later. And then our outcome measure is a grammar test. This data set is also in wide format. So we're going to have to melt that one too. Okay. But if I look at group here, group is not factored. So a lot of times with Ggplot, what half the time that you spend is fixing the stupid data set to be the right style. It needs to be factored and in long format. All right, so let's import that data set. It's texting. I'm on line 203-ish. My texting data set imported with the stupid I thing, so I'm going to fix that. Okay. Or none of the rest of this will work, so I'm going to put it right here. So call names, texting, square brackets 1. I'm just fixing the first column. So last week when we talked about how to index things, it says pull the first one. That's where that square brackets thing comes from. And it is group with a capital G. Done that correctly, the little group thing will go away. And then now I'm going to factor group. So I think a lot of the frustration at the beginning comes with the fact that sometimes if you run lines more than once, you undo something you did. Factoring is one of those things that you can only run it once or you have to re-import the data. But if I re-import the data, I might screw up my column names. So one thing that you kind of figure out along the way is what order to put things in, and kind of like a note to yourself, like only run this once. I can't tell you the times number of times that I've rerun a factor. Don't do this. I'm gonna do it though. And wiped out my factor. Okay. Just by accident, I ran it twice. If you run it twice, it wipes it out. All right. After I run it, we're going to melt things. Okay. This is a mixed design. I have between subjects and repeated measures, so it's a mixed design. So I'm melting that data set. I'm leaving one of them alone, which group they're in. And I'm melting the other two. So this is time. So I'm going to run those. Make sure I don't get ahead of myself here. And then I'm going to fix those column names to be time and grammar score. Now I could have had a space here, but that's a variable name. So if you put a space there, it's going to put the space in the, sorry. Click here. Click on long texting here. So why do I have it with an underscore? Because otherwise it would have made the name of this variable with a space, and I've warned you, just don't do that. Because the way that you have to reference them comes up really funny. Hair on my face, sorry. So variable names should not have spaces. It lets you do it. I wish it wouldn't. Because then you're going to have a really hard time like getting it to use the variable name right. Okay. After all of that, let's talk about the actual plot. It's so big I couldn't get it to fit, really. So I'm using my long data set. My aesthetic is X, Y. Color this time. Okay. So color instead of fill. Because we're making a line graph. So we're coloring the lines instead of filling the bars. And then the rest of this has stayed the same, except that this is the important part right here under aesthetics. Group equals, okay, instead of 1, because I have more than one group now, I have the name of the variable, which we call group. Okay. So it's not always group equals group. It's group equals name of variable. The rest of that will stay the same. But down here, we started today with a double bar graph where we did scale fill manual. This is scale color. So whatever you use up here, in the description of your graph also has to use down here. So if you change this to fill, this has to also be fill, or it won't do anything. You'll be frustrated, like, why isn't this working? And I do believe if you ask Jessica, this is when I actually figured out what was going on. So I was like, scale fill should work, that would be fine. She's like, no, it doesn't, damn it. Because it has to match. So we had that learning experience last year. I don't know why that took so long to click, but it does. They have to match. All right, let's run this thing. And you should get this graph. Minus the error bar problem. Which is what this graph is. So just when would I use a bar graph, when would I use a line graph? I'm going to use a bar graph if there are groups, a line graph if there are groups, but they're sort of continuous. Generally, the bottom is something like time, or like Dr. Mitchell's lab uses a heartbeat number, right? That's kind of continuous, right? He does like 3 beats before and 3 beats afterwards, but that's moderately continuous. If the data is completely continuous, you're using a scatter plot with a line. It's slightly different things. All right.